Namaskar. Today I will teach you the very important topic quantum numbers. They are very important. Quantum numbers tell us the complete address of an electron. They tell us about the shell, subshell, orbital, spin and energy of the electron. But let us first of all study where these quantum numbers identified from. Let us find out their origin first of all. We have a wave equation which is called Schrödinger wave equation, and according to this equation, curly 2 psi by curly x square plus curly 2 psi by curly y square, curly 2 psi by curly z square plus 8 pi square m upon h square e minus v psi is equal to 0. This is the Schrödinger wave equation, and it is clear that wave function psi depends upon x, y and z. Means wave function is a three-dimensional quantity. And now this is the total energy and this is the potential energy. When potential energy is subtracted from the total energy, then this will give the kinetic energy only. So this is the Schrödinger wave equation. When this Schrödinger wave equation was solved for H atom, when this Schrödinger wave equation was solved for H atom, then so many solutions were found, and in those solutions there were constant numbers n, l and m, and these are the quantum numbers. So these quantum numbers were found from the solutions of Schrödinger wave equation for H atom, and these are the quantum numbers. This is the principal quantum number, and this is the azimuthal quantum number, this is the magnetic quantum number. So let us first of all study each quantum number in detail. Number 1 is principal quantum number. It is represented by small n, and principal quantum number tells us about the shell of the given electron. For example, if n is equal to 1, 2, 3, 4 and so on, then shell will be first, second, third, fourth and so on. They may also be regarded as K shell, L shell, M shell, N and so on. So principal quantum number tells us about the shell of the electron. It also tells us about the energy of the given electron with the help of this relation. En is equal to minus 1312 divided by n square kilojoule per mole. This n is principal quantum number and its value is 1, 2, 3, 4 and so on. But it should be clear to you, with the increase in n, the energy will increase. N is in the denominator, but with the increase in n, energy of the shell or energy of the electron in the given shell will increase because of this minus n. So principal quantum number tells us about the shell, energy, and other main thing is it also tells us about the main line of the spectrum. When we obtain different spectra, then there are so many peaks and lines. The main line of the spectrum is explained by or expressed by this principal quantum number. So this was the principal quantum number. Now we will have azimuthal quantum number. Number 2, azimuthal quantum number. It is represented by L, and azimuthal quantum numbers have so many other names also. It is also called subsidiary, secondary, or angular quantum numbers. These are the other names of the azimuthal quantum number. And azimuthal quantum number tells us about the subshell of the electron. It tells us about the subshell of the electron, but its value depends upon the shell, or you can say the principal quantum number. For example, if L is equal to 0, 1, 2, 3 and so on, its value, as I have told, depends upon the principal quantum number, and its value extends up to 1 minus the principal quantum number. Then subshell will be S, P, T, F, and we require only these much subshells only. But if it will be 4 and so on, then it will be G, H and so on. So L will tell us about the subshell. Its value starts from 0. So this S means sharp, P means principal, D means diffused, and F means fundamental. So these are S, P, D, F subshells. And this also explains the fine line of the spectrum. This principle, this depends upon principal quantum number, and it tells about the fine line of the spectrum, you can see. And after that, we have third quantum number, which is called magnetic quantum number. And obviously, magnetic quantum number depends upon this azimuthal quantum number. Magnetic quantum number, it is represented by M, or sometimes ML, because it depends upon L, the azimuthal quantum number. Magnetic quantum number tells us about the orbital of the given electron, or you can say different orientations of the electron into the given subshell. So it depends upon the azimuthal quantum number. For example, the value of M is minus L to 0 to plus L. with the difference of unit, m has values from minus L to plus L. For example, if L is equal to 3, then according to 0, 1, 2, 3, S, P, D, F, what will be the subshell for L is equal to 3? When L is equal to 3, the subshell is F. And now M will be from minus 3 to plus 3. The value of M will be from minus 3 to plus 3. 1, 2, 3, 4, 5, 6, 7. Means there are 7 orbitals. 7 orbitals. You can see the number of orbitals depend upon the subshell. If the subshell is 3, then the value of M, if the value of M is 7, then there will be 7 orbitals. Likewise, if L is equal to 2, then subshell will be D. Then the value of M will be obviously from minus 2 to plus 2. 1, 2, 3, 4, 5. So there will be 5 orbitals. So it is clear that the value of M tells us about the orbitals and it depends upon the value of L, means azimuthal quantum number. So it is very clear that M depends upon L and L depends upon N, the principal quantum number. So these were the 3 quantum numbers which were found in the Schrödinger wave equation or in the solutions of Schrödinger wave equation. And these quantum numbers tell us about the shell, subshell and orbital. But in this equation, there was no quantum number or no constant number which can tell us about the spin of the electron. So, spin quantum number was introduced later on. Spin quantum number was introduced later on, and now we have 4 quantum numbers. So, the 4th quantum number is spin quantum number. It is obviously represented by small s, and it tells us about the spin of the electron. And if s is equal to plus half, then it is considered to have clockwise spin, and if s is equal to minus half, then it is considered to have anti-clockwise spin. But as electrons revolves in the 3-dimensional space, so the reverse is also true. If we have taken, if s is equal to half, then clockwise spin. But for s is equal to half, anti-clockwise spin is also possible. But generally we take this. For s is equal to minus half, there is anti-clockwise spin, but clockwise spin is also possible. However, this is the convention that for plus half we take clockwise and for minus half we take anti-clockwise. And this is the 4th quantum number, and it tells us about the hyperfine spectra of the electron. It tells us about the hyperfine spectra of the electron. So this was the concept of quantum numbers. And if I will ask the question in the end that how many quantum numbers are required to explain the orbital of the electron, then obviously the answer will be 3, because orbital quantum number is the magnetic quantum number and it depends upon the azimuthal quantum number, and azimuthal quantum number depends upon the principal quantum number. So all the 3 will be required. And if I will ask the question, how many quantum numbers are required to explain the subshell, then obviously for subshell we will use the azimuthal quantum number, but it depends upon the principal quantum number, so that will also be required. So to explain the number of subshells of the given electron, we will require 2 quantum numbers. The subshell will be directly explained by the azimuthal quantum number, but obviously it also depends upon the principal quantum number. And the other important aspect of the quantum number is that if I will ask out of 2D, 3D, which is possible and which is not, this can be explained by the quantum numbers only. For example, for 2D, n is equal to 2 and n will be equal to 3, like 0, 1, 2, 3, S, P, D, F. For 2D, n is equal to 2, and for D, L, we will have L is equal to 2. And this is not possible, because I have told you before that the value of L is always from 0 to n minus 1. Value of L is from 0 to n minus 1. If n is equal to 2, L will be 0 or 1. It will not be equal to 2. And in this case, n is equal to 3, and for D, L is equal to 2, and it is possible. So we can say that 2D is not possible according to the conditions of the quantum number, and 3D is possible. So this is what is all about the quantum numbers, and they are very much helpful as they tell us about the complete address of the given electron. Thank you very much.